My name is Jacob Unser, or Albert Unser. I'll be talking about databases and really more specifically SQL and NoSQL databases. I'm going to start with a quote by Elon Musk. He says, if you go back a few hundred years, what we take for granted today would seem like magic. Being able to talk to people over long distances, transmit images, flying, accessing vast amounts of data like an oracle. These are all things that would have been considered magic a few hundred years ago. And it really does have a good point because today's technology is so advanced that it seems very surreal. And it's something that will only increase, only make things more efficient. And like I said, today we're going to be talking about databases and really, I guess, SQL and NoSQL. We're going to hit on all two of those. So database simply is an organized collection of data. It is the collection of schemes, tables, queries, reports, views, and other objects. And it's not only a collection, it's a storage as well. So examples, some applications, they support internal operations of organizations and online interactions with customers and suppliers. It's really can be used and applied to any company. Any company can use something like this. There's examples of internal operations, library systems, flight reservation systems, computerized parts inventory systems. So very vital for any company that has really any information that needs to be stored. There's four main functional groups. First, data definition, which is the creation, modification, and removal of definitions that define the organization of the data. Then you have update, retrieval, which is providing information in a form directly usable or for further processing by other applications. The retrieved data may be made available in a form basically the same as it's stored in the database, or in a new form obtained by altering or combining existing data from the database. And then last, but not least, you have administration. The history first begins with Edgar F. Codd in 1970, as he first proposed the relationship model, which departed from the traditional one, insisting that applications should search for data by content rather than by following links. The present day, some of the databases you have are IBM DB2, Oracle, MySQL, Microsoft SQL Server, DBMS, and then, of course, late 2000s here, we really have next-gen databases, which include NoSQL, key value stores, document-oriented databases, and really all of this is just going to be increasing in technology and efficiency. So one example, one database we're going to hit on is SQL, and it kind of deviates in several ways from its theoretical foundation, as SQL tables and queries are lists of rows. The same row may occur multiple times, and the order of rows can be employed in queries. Now, SQL was developed at IBM by Donald D. Chamberlain and Raymond F. Boyce in the early 1970s, and was designed to manipulate and retrieve data stored in IBM's original quasi-relational database management system. So like I said earlier, in design, deviates in several ways from that foundation. The relation and tuple calculus use different rows. That's kind of what the difference is between this database and the others. Some of the language elements include clauses, expressions, predicates, queries, statements. Clauses are components of statements. Queries, expressions can produce either scalar values, tables consisting of columns and rows of data. These are all very key to the language elements. And then another example of database, NoSQL. So you can see kind of the uses there. Google uses it, Amazon, there's MongoDB. Which provides a mechanism for storage and retrieval of data that is model means other than tabular relations used in relational databases. So it's just a little different in that sense. Doesn't go straight away a little bit from the tabular relations. So the importance of all this is that data can really be endless. You cannot have enough data, you cannot have enough information, and you need to store it in an efficient way and get that collection of data easily. This is something that's extremely important for any company, any service, but it's also important for users and individuals. There's so much stuff that needs to be stored, so much personal information. So the future, and I found an interesting quote by Neo Technology CEO Emil Eifrom. He said, if you're interested in seeing the future of how data-oriented architectures are likely to evolve, the future is already here, just unevenly distributed. So he makes a good point in that we have maximized what we can, but we're almost there. Our data and our technology is so advanced that it's something we just need to build off of, and it's coming very close. That's all I have about databases. Thank you for listening.